Welcome to this video. We will be looking at measures of variation, and it's generally variation around the mean value. So the first one, we'll take a look at the range. The range is very straightforward. You are simply looking at the distance from the maximum value to the minimum value. That's all. So we will take an example. You have this data set and you want to compute the range. So you simply look for the maximum value and the minimum value. And how do you do that? You first of all order the data set, and once you order it, you are able to compute the range, which is the difference. And the range is simply 10. That's it with the range. Very straightforward. The next one is computing the deviation. Why do we want to compute the deviation? Because later on we'll be taking a look at the standard deviation. Now let me give you an example to help you really understand the deviation. So let's say you are interested in the price of burgers in different restaurants in Montreal. Now you want to know what you should expect when you go to a restaurant. So what we will do is we will generally take a sample of the price of burgers in restaurants in Montreal, and we will look for the mean value. The mean value gives us what to expect when we go to a restaurant. However, when you go to some restaurants, it may be above or below that mean value. Some restaurants may be cheaper, some may be more expensive. So the deviation simply tells you how something deviates from your expected value or from the mean value. That's what we are going to compute here, and later on we'll put it in the form of standard deviation. So you basically have your mean value here. Here you have the mean value, and you simply want to, so for a particular restaurant, let's say the mean value is 10. If in a restaurant, maybe the value is 12, so your deviation will be 2. So it is 2 higher than what you should expect. And let's say it's 8. If the price of burger is 8, then you have 2 less than what you expect. That's just what deviation is. So let's take an example. So here you have your data set. What you need to do is first of all compute the mean value. We are talking of 10 graduates, so you will add this and divide by 10. So once you add it and divide by 10, you have this as the mean value. What you need to do now is you can just build a table, and once you have the table, given that this is your mean value, 41.5, you can now look for the deviation for each of the values. So 41 minus the mean value gives you a deviation of negative 0.5, and here you have the different deviations. You have your mean value, you are just looking at the difference, the value, how it deviates from that central value, which is 41.5. That's what it gives you. And in general, if you add the deviations, you end up with 0. So generally, we will use squared deviations, but that's it for your deviation. Now we move on to the next approach, which is the variance and also the standard deviation. So here you have your deviation. So you are dealing with squared deviations divided by n. That will give you what we call the standard deviation. However, when you square your standard deviation, you have what is known as the variance. In other words, if you have this is the variance. In order to have the standard deviation, you take the square root of your variance. So generally, we will compute the variance. So you see the sum of squared deviations. Initially, here we had computed the deviation. So if you want the sum of squared deviations, you simply square each of these values and you take the sum. That will give you the sum of squared deviations. Because if you simply sum the deviations, you end up with 0. So you always need the sum of squared deviations. So you square each of the deviations. That's what you get here. Then you take the sum, you divide by n, which is your sample size. This is your population size. Sample size is small n. Population size is capital N. So when you do that, you end up with a population variance, and if you want the population standard deviation, you simply take the square root. We will take a look at a couple of examples to make it really clear. So generally, this is the algorithm you should follow. You start by looking for the mean of the population. Once you have the mean, you look for the deviation of each data point, and then you square the deviation. You look for the sum of the squared deviation, and then you simply divide it by the population size. That will give you the population variance, and if you want the population standard deviation, you simply take the square root. And we will also see the case for the sample variance and sample standard deviation. So here it says find the population variance and standard deviation. So we start by computing the mean. Here we simply say you don't need to recompute this because we already did it. The mean value, which is mu, is 41.5. So use it immediately to compute the deviations. We had already computed the deviations. Here we go. So now we need to compute the squared deviations. It means you square this, and for each point you have the squared deviations. Once you do that, you take the sum of squared deviations, which is 88.5. And once you have the sum of squared deviations, you now divide it by n in order to have the population variance. So here is your population variance, and if you want the population standard deviation, you simply take the square root of that value and you end up with that. So it's very important to always, once you create your table, everything is so easy to compute and you don't have any issues. Now let's move on to the sample variance. Now the only difference is that for the sample variance, you no more use capital N, but you use n minus 1. Okay, you use n minus 1, and for this sample standard deviation, you take the square root of what you have here. Now let's take this example you are dealing with. Here in this case, we decide to say you are dealing with the sample. So you do exactly what we did in the previous example. You know what the mean value is. So you look for the deviation, the squared deviations. Now, when you come, you no more divide this by n because you have small n indicating you are dealing with a sample. So you will divide 88.5 by n minus 1, which is simply 10 minus 1, 9. So here we go. You have 88.9 divided by this. This is what you have. This is your sample variance, and then you divide it. You take the square root. You end up with this for your sample standard deviation. Now it's very important to take note of the notation. So you are using S when you are dealing with the sample variance and sample standard deviation, but when you are dealing with the population variance and population standard deviation, you are using sigma. Okay, it's a Greek word. You use sigma when it's population, but when it's sample, you use S. Now let's keep the momentum rolling. Let's see how to interpret standard deviation. Now remember what we've said about a burger in a restaurant in Montreal. So standard deviation is a measure of the typical amount an entry deviates from the mean. So if you know, for example, that the mean price of a burger is $10, and you also told the standard deviation is $2, then when you are going, you expect that the price may vary by $2 less than the standard deviation, or $2 more than $2 from the mean, or both ways. In other words, you expect the price of the burger to normally go from $8 to $12. Now, $8 to $12 means one standard deviation away from the mean or one standard deviation above. Now, there are cases where you may have 2 standard deviations away from the mean. Now, abnormally, you will have more than 2 standard deviations. That's an abnormal situation. So let's take a look at this graphic. So in this case, you have your average value as 5 and the standard deviation is 0. 0 simply means, so let's take the example of the burger. It means every restaurant is selling at the same price. There is no deviation from the mean. In this case, the standard deviation is 1.2. It means you expect it to vary to the left or to the right by 1.2. That's why you have that. And in this case, the standard deviation is 3. It means you expect your variation to also behave that way. Okay? You can see the variation from the mean value is pretty high here. And here it's just 0. Here it's not so bad. Okay? Now, we are going to be talking about this rule, interpreting standard deviations using the empirical rule. Now, I will use the graphic to explain this concept of the empirical rule, which is simply the 68%, 95%, or 99.7%. Okay? What does it mean? Graphically, you can see that for any distribution that has this shape, it's generally called the bell-shaped distribution or the normal distribution. So if you take a look, you expect that the mean value lies at the center and you have exceptional values lying here. Okay, most of the time in a class, for example in the QA class, most students will be around the center. If you look at the height of students, most students are around the center. Some students are at the lower end and some students are at the higher end, but they are pretty few. The height is mostly around the center. The width is also around the center. Now, here you have 1 standard deviation away from the mean, away to the left, away to the right. So you expect 68% of your data set to be 1 standard deviation from the mean. You expect 95% of your data set to be 2 standard deviation. So it's 2 standard deviations. So it will cover all of this area, and 99.7% of your data set to be 3 standard deviations from the mean value. That is simply what the rule tells you. So this is only valid for data sets which are normally distributed. Okay, so when we say 68%, it simply means 34 here, 34 to the right, 13.5 plus 34 to the left, 13.5 plus 34 to the right, and the final one. That's what it looks like. So it's important to remember these numbers. So if I tell you, if I give you, well, we'll take a look at some questions and you'll see how to play with it. So you are being told that the sample mean height of women in the United States, here you go with the age, and this is the mean, with a standard deviation 2.62. Estimate the percent of women whose heights are between this and this. So you are looking for the women who fall within this. What's the estimate? Now what you want to do is to look, this is your mean value and this is the standard deviation. Now what are we saying? How many? You can see that here this value does not deviate from the mean, but this value deviates. This value deviates by how many standard deviations? Let's try to understand it. So you can see here you have the 64.3. It means we are somewhere here, and it also means we are rather deviating to the left, and we want to understand by how many standard deviations. So let's take a look at it. If you take a look here, you will see that 64.3, if you do minus 59 point this, you will see that you are talking of 2 standard deviations. 2 standard deviations is what percent? It's 34 and 13.5. So you are simply saying 47.5% of women are between 59.06 and 64.3. How do you know that? It's from the empirical law. How do you know it's between this and this? It's because you've been told that the standard deviation is 2.62. So if you do 2.62 minus 64.3 2 times, you will end up having this. You will end up having that. Okay? Now, let's look at the final part, which is the Chebyshev's theorem. Now, should I cover? Should I not? I'll let go Chebyshev's theorem, and I'll see you in the next video.